Hey, thanks, and thank you all for coming here, and especially thank you for having me. I'm Sebastian, and go by Seb. I spent the last 10 years in Singapore, and just got here with my lovely wife, Alyssa, 2 weeks ago. So I'm very new in town, and I love speaking at meetups. The first thing I did 10 years ago in Singapore was start a meetup about Node.js. It's called Beer Mates. Turned out nobody really drinks beer over there. So now it's like different names and stuff. The most recent ones I did were all mostly about web performance. And it was kind of an excuse for me to talk about my open source project that I've been sort of indulging in for the last 3 years. And I'd love to share that with you now. And it's not going to be as much code, but it's going to be more like the idea and what I've done so far and maybe a little bit of what's coming up. I'll go fast. There's quite a lot to cover, and it might be too much detail, so I might skip things. So anyway, that's me. I'm looking for people in Austin, sort of I know no one here, like just my wife and I. I might be looking for a job at some point, but I just had one for 3 months, and that's like that's enough funding for me to work on open source again for a while. So a couple of years ago, I started experimenting with HTTP2, sort of like how can you do away with Webpack and Browserify and just bundle your front end assets, because I was doing mostly front end development for like various startups. How do you do that at the protocol level with server push? There's a concept in HTTP2 where the server can just like push a whole bunch of files down the wire and avoid all the round trips from the client. And so that led to working on Node.js core, on the HTTP2 module to implement push and a bunch of other little things that I was sort of supporting. It's not like a major contribution, but it was fun. And it sort of exposed me to like working on a large scale open source project, which was really interesting. And I try to bring that into all the work that I do now. So last year I started using a lot of HTTP2 code in Node.js as a way to build something useful with that, which turned out to be a CDN. Because how do you host websites? You put them on the CDN, so they have locations around the world to minimize latency, make it really fast. And so that was a really interesting learning journey. Everything's open source. It's all on GitHub and mostly GitLab, actually. It's called Commons Host. I went through some name changes. The idea is it's a joke on the futility of the whole system, where it's meant to, somebody working at a large CDN described it once as it's one successful user away from failure. So anyway, we just recently moved, and the most recent stuff that I was working on prior to the 3-month job, fundraising, was DNS over HTTPS. Anyone familiar with that at all? Is that like a well-known thing yet? Yeah, okay, some people, that's awesome. This is basically a way to make your DNS secure, resistant to like spying by your ISP or government censorship, depending on where you live. And it just gives you a good feeling that you have more control over all your queries and all the domains that you're doing on your own network. And so I've implemented that. And I think the first implementation was Cloudflare. It's like a big CDN company. And the second one was me and a friend of mine. Basically, we hacked on this for a couple of days and put out a Doe DNS over HTTPS service on the same CDN, because it just runs as a website, really. It's like, instead of like 8.8.8.8 or 1.1.1, you just have like a URL. So in this case, you just do like https://commons.host. That's your DNS resolver. And sort of that's been there for a while, and it's very popular now. Last year, I gave this talk, or an earlier version of this talk at NodeConf, and it was like 30 pops, like 30 sites around the world. They're mostly running on these little tiny computers, like Raspberry Pis and Odroids and all of that. And some of them are VPSs, and like it's really cheap to get the hardware to run a big network as long as you coordinate it. And so I've got a bunch of people who are sort of like attend the talks or like that I know online, and I found out about it through the blog or Twitter, and they're like, okay, I'll just put one at home in my office, whatever, wherever, and they contribute a little local node to the network. There's a bunch of security implications there, and it's really fun challenges. But the rate of growth is really the goal here. To get a huge coverage globally with a CDN, you need to have a really high growth rate. And I don't have any capital really to put into this other than my time. And it's entirely self-funded and all of that. So basically people are just voluntarily contributing to it. So if somebody put up a YouTube onto the CDN, it would die, right? That's what I was mentioning earlier. But so far it's like static sites and small things, and it's working pretty nicely. It's amazing. So yeah, I've been working mostly with these Odroid servers. That's kind of like before Raspberry Pi 4 came out this year. That was the sweet spot, like around $50. You get like a pretty nice like a little ARM CPU, a couple of gigs of RAM, and you could plug in a little SSD. So you can have like a little hard drive in there that would cache content, and then you just place these around the world, and you have like a little cache everywhere. So I have a little command line tool. You can deploy a static site to it. That was the first use case because I actually built this whole thing because I wanted to build a website, and I was like, how do I host a website? And went down that rabbit hole and never stopped. So you have a little command line tool. Anyone can use this. You can create a little website with, like, it's free. There's no limits really or anything like that. I think there's a little bit of abuse for checking, but nah, sometimes somebody breaks it. That's fine. It does like custom, like, let's encrypt integration. So you just have your own domain name pointing at commons host with a CNAME or whatever you use, and then run the deploy command, and it'll do the let's encrypt thing. So you get it only serves HTTPS, right? So that's kind of like a thing with HTTP2. You have to do HTTPS. Server push. Oh, this is like a really cool tool. I won't talk about that here. Because again, I really wanted to use server push. So I have a whole thing that, parses HTML, CSS, JavaScript, SVG, whatever, and builds the dependency tree, and then turns that into a manifest that I can use to push all the assets. And you can transpile it to, like, not just this service, but you can just transpile it to any configuration for any web server or other CDN. There's a whole bunch of stuff there. It's kind of fun. There's documentation where you can read it. I'm not going to give a talk where I'm just talking about doing the README, right? So anyway, I started about 10 years ago in Singapore with the realization that internet was pretty slow, DSL cable, and it was far away. There's no data centers or internet exchanges, so anything that you download on the internet, it's really slow and far away. Like it's about, what is this, 20,000? Like 10,000 miles or something. So it takes 250 milliseconds round trip time from Singapore to, like, servers in California. It just really doesn't feel right. Singapore today, hey, okay, that's a picture of where I just worked for a few months. That's coincidence. But it really looks like that. It's super futuristic and it's fantastic. Internet's really fast. You can get 1 gigabit fiber to the home in, like, a tiny fraction of your income. And this applies to like 99% of all apartments, which is what everyone lives in. So there's also a lot of infrastructure has been built in the last decade for data centers and internet exchanges. So internet is really fast now. Like you can ping Google or Facebook or Akamai or whoever within like 1 or 2 milliseconds from your home, which is crazy. And sort of the realization that Singapore is like sort of in the middle of the circle almost, and a lot of people live really kind of close by, and they have similar. This is just like numbers to get you an idea of where I'm coming from. Like the left quartile of the screen, it's about 1 billion people. Then like Africa, Europe, about 2 billion, and the majority of the world lives in the right-hand side of the screen. Similar infrastructure is being rolled out across Asia, and it's kind of really interesting. Most fiber users actually live there, and the reason is this. So if you've visited Asia cities, it kind of looks like this. This probably could be China, but it could be Indonesia, it could be Thailand, it could be anywhere. It could be India or someplace. This clip goes on, and this doesn't loop. It just goes on and on and on. It's pretty cool. I mean, if you like urbanization. The thing that this provides is like a density of something like 100,000 people per square mile or whatever, and it makes it really cheap to deploy like fiber internet, because if you're building new apartments, you're going to put fiber for the same price as you would put like coaxial cable or DSL phone lines and whatever. So you might as well put fiber, and so people do, and everyone just has really cheap, super fast internet in their homes. And I started realizing that, okay, the problem is in a lot of these places, kind of hard to do business. So data centers and internet exchanges, deploying those, like as if you're a foreign company, it's kind of difficult to do that. So you end up sort of clustering them in the business-friendly locations. So the top ones are really huge cities, like Bangkok, Ho Chi Minh City, Yangon, Kuala Lumpur, Jakarta, Manila. Tons and tons of people, very, very little infrastructure, very hard to do business, very difficult to invest. But the bottom ones are like Singapore, Hong Kong, and Tokyo. Very easy to start a company. It takes like an hour. And so a lot of companies put fiber there, and you have really, really fast connections. So in all these other places where most of the people live, remember that little circle, most people in the world live there, and most of them live in these cities that don't have that much connection. Internet still sucks. So internet's not really sort of homogeneously distributed around the world. There aren't like a bunch of different data centers in Greenland or whatever here, as shown in these concept art. Internet's very lumpy. it works through peering. So you have networks like an ISP talking to another ISP, crossing other ISPs, and that whole process is called peering. It's a very weird world where a lot of things are still manual. If you have like a really huge ISP that has a lot of like long distance cables, you're going to charge to send data across. And so small ISPs, they want to have CDNs on their own network, right? So they want to have a little server sits with them so that they don't have to transfer like across a big network and pay for that. They want to have a little local cache. So every little ISP in the world, which is like tens of thousands of them, they want to have little local caches. It makes things faster, cheaper, et cetera, et cetera. In the real world, it means like if you have a small ISP in Thailand and a small ISP in Singapore, this is a use case that I pulled up from my home well, a couple of weeks ago. Sometimes traffic goes through California, which is ridiculous considering the distance. It means something like 15 milliseconds ends up taking 250 milliseconds. And it just costs way more, and the pipes get congested and all of that. So this is because small ISPs don't have the manpower to negotiate with every other small ISP, and they end up falling back to internet exchanges that are like often based in California. So that's internet exchanges are like how networks talk to each other. They physically wire to the same building, go onto a switch, and then negotiate how they can exchange traffic. And then there's like sort of these like really big networks that fall back to that everyone else subscribes to as well. But that ends up being slow because you have to go around the world. So traditionally, sort of the idea is you want to make websites fast, put them on CDNs. CDNs put a cache with every single internet exchange in the world. Maybe like a couple of dozen gives you really good coverage. A couple hundred will give you insane coverage. I'd like to just bump that up by a few orders of magnitude and put a cache at every single ISP. Maybe every single cell phone tower. I think that would be hilarious. So if you think about how many there could be, I think there's a bound around 60,000, 50, 60,000 active like networks. ASN is like an autonomous system. It's basically like an ISP or a university network or something like that. A big company with a lot of offices. There's about 1,000 cities that have more than 500,000 people in the world. So I'd say maybe like 100,000 locations would be a good sort of upper bound to shoot for. I'm starting really small. Okay, I started with $200 servers. I'm drastically lowering the budget now. It's probably like costing me about $50 per server. They can do a gigabit per second, which is the big thing with the Raspberry Pi 4. And I'm really just serving static sites. And even that use case, so you can saturate a 1 gigabit network interface with a Raspberry Pi or a Node-Droid. But I still think it's a bit too high of a server load to do static sites. I'd rather do DNS, like DNS over HTTPS thing. I think that's a good use case. Yeah. Where did I? Oh, right. So BGP is sort of a protocol that networks use to declare to each other which IP address ranges that they are responsible for, or that they can route to. And so this number is essentially networks announcing on internet exchanges. It might be Hurricane Electric or some company that has a presence on lots of internet exchanges around the world where they listen for this BGP announcements. And each announcement basically says like, you can send me traffic for this IP address range, and this is my number. And so this is something like that's essentially like there's no definitive list of how many are there. It's more like you just listen, and you have a lot of points in the world where you're listening for all these networks. It's a bit weird because like in some parts of the world, like mostly China, there's caveats where like you have like a couple networks only, but they actually have a ton of different networks internally. So they have like a little mini internet within an ISP almost. So this is an approximate number. More or less, yeah. It's like if you're on if you're on like let's say for example, like if you're on AirDrop, and like with I don't know if you use Mac or Mac products at all, but I have a thing that you announce like or which AirPlay what's it called, AirPlay, right? Or AirPlay or what's the Chromecast? Do you announce on your local network like I'm looking for something, and these devices are announcing what they're capable of? That's similar to how BGP works, but this is for like ISPs, sort of saying like I have this, I can give you these IP addresses if you send me traffic. I hope that answers your question. Thank you. Okay, so in the first couple of months, went up to 20, then 30 locations, and I figured it wasn't really fast enough, so I mostly stopped doing that route. Although I'm still welcome if anyone's interested in deploying a server at home, talk to me after. did a lot of automation around this stuff and make it really easy and seamless so I can keep focusing on actually functionality and not DevOpsy stuff. I'm mainly leveraging JavaScript, this whole fiber revolution that's taking place, and commodity hardware like ARM chips that are in all these single board computers. So firstly, Node.js is just totally awesome. It's the best thing in the world. Everyone should use it. It makes you super powerful. If you have JavaScript and Node.js, you've got all these amazing built-in libraries, batteries included, and it runs cross-platform. So I can compile this. I can run this on like a Mac, and then I can deploy it on an ARM server or an Intel server or an AMD server. It's really, really easy as a sort of a single developer or a small team to be really, really empowered. And then NPM, you just have so many things available to you that are open source. Okay, fiber. Oh, this is my apartment. On the left-hand side, you'll see some kind of data server rack. On the right-hand side, you see apartments. And I think I used to live on level 33 in the second building. They both have, in both cases, each unit has about a 1 to 10 gigabit fiber connection. And each rack will have like a 40 gigabit uplink. Each building will have a 40 gigabit uplink. So there's similarities. And I've been trying to leverage some of that by using these cheap hardware and deploying them in all these random apartments around the world, or office buildings, whatever. These are really efficient, low power, quick performance per watt. And this is something that has happened before. I don't think this is really revolutionary, but I think it's sort of like repeating a similar thing. 20 years ago, Google was really cool and came up with this new thing. And it's a search engine, but actually what they came up with was using commodity hardware like Intel CPUs to be more efficient than using big, powerful, mainframe computers or fancy, enterprise level servers that would cost like $1 million. They would just like, oh, here's like $1,000 server. Now here's a $50 server. That's sort of the same idea. So blah blah blah. Okay. So basically, this gives me like a totally unfair advantage because I can put, small servers everywhere. And the reason is that phones have made ARM CPUs super, super cheap, especially if you look at like, a couple generations ago. Sorry for the unnecessary animations. Basically, they become super obsolete really fast, and because of that, nobody wants them, so the price drops dramatically. There's tons of these available. They all are based out of Shenzhen, where like tiny little shops, you can buy enormous inventory of like hundreds, tens of thousands of the same CPUs for pennies. You slap them onto a little board, and you publish that. You publish a website, and you sell these things, and that's sort of like the Raspberry Pi story, right? So this works. This is super cheap, and this is way more efficient if you want to have a lot of individual servers than saying like, oh, we're going to run on like Intel servers or AMD servers. So similarly, there's like a little bit of growth in server CPUs. This is like the number of CPUs that are being shipped. So you can tell ARM, just like most of these phone CPUs, it's just enormous. So the amount of innovation and the amount of optimization and compilers and all this other stuff is really, really strong. There's a ton of them. Sorry, I'll skip through most of this. This is not an ARM sales pitch. Okay, so actually the latest ARM stuff, they're pretty good at doing crypto, which was always sort of like, you don't have that much CPU power, so how can you saturate 1 gigabit when you're doing TLS? Because HTTP2 is all TLS, which means like HTTPS, like encrypted stuff. So nowadays, actually it's pretty fast. It can do it. It's amazing. This is something that has only happened in the last 1 or 2 generations of these little boards. So it brings it back to the little servers. So this is an older Raspberry Pi. I just use this for my DNS at home. But sorry, I'm showing the case for the Odroid. I didn't bring that one, sorry. So I want to create like a really huge CDN, and by large I mean like the most number of servers, which means like I want to have a server on every single ISP in the world or network in the world. That's the only way you can be like essentially free, because at that point you get free bandwidth when you have free peering with every single network. Bandwidth. That's how you build a YouTube, but way bigger. So how do we do this really fast? Well, sort of the approach that I've currently been taking is just sort of like ask people to like, hey, do you want to buy or contribute some of your own hardware to this project? And it grew pretty fast. So in the first like 8 months, we grew faster than I think somebody from Cloudflare, I won't mention names, I guess, but like grew faster than them in like the first couple of years, so in the first couple of months. So it's pretty fast, but it's still not like an exponentially faster thing. I think the DNS angle is a better one, and that's something I've recently realized. optimized. So sticking with the cheap hardware stuff, okay, skip through some of this stuff. This doesn't matter. Okay, so the DNS stuff. If you're not using this stuff yet, you should totally check it out. Okay, if you're using things like DNS over HTTPS, you'll have way more privacy at home or in your office. And this has become very popular, and a lot of people are finding out about this. I don't know about policies with ISPs here, but like in many countries in Asia, there's a lot of censorship, like pornography, copyright, things like that. And then in some countries, it's a little bit more political, and people who want to, have a little bit more internet freedom and internet privacy, they use, encrypted DNS. And there's a bunch of different methods of doing that, and DOH, DNS over HTTPS, is really, I think, a nice way of doing it because it's compatible with a lot of current web infrastructure. So it's easy to deploy this like along the lines of a static website. It takes advantage of HTTP2 having these really long-lived connections. So your DNS round trips don't have to set up a new connection and a handshake every single time. It just builds in sets up connection once. Everything is encrypted, and it could be a connection to like some website, and then that website just happens to accept, like your content type header for like DNS message, and then it'll just respond with DNS responses to your queries. So a nice thing of having servers on every single network is that you get local caching for DNS. So you don't want to have like one big DNS server for the whole world. You want to have it globally distributed, so you can serve like geolocated content to route people to closer servers for websites. But you still want to have a good, sort of shared use of cache, which is why ISPs put them up in the first place, is to sort of all their customers could share the same DNS cache, and things could be fast for their customers. It's only then later on that they got access to all that data, and they were like, we can monetize this, or we can legislate this. Right? So if you put that back into people's own control, I think you get back to that original benefit of the performance without the creepiness. So two projects that we've been working on. One's called Playdoh, the other one's Donut. Basically, my friend here, Kenny, he said, like, how hard can this DNS stuff be? And pretty much like using Node and NPM overnight, put a little proof of concept together, and then I spent a week deploying that into production, and we had our own little DOH service. It's called Playdoh. This is like a middleware for like we use Fastify. Well, actually, no, I think I use Connect still. Connect, Express.js, Fastify.js. These are all like popular Node.js web server application frameworks. And Playdoh is just a middleware that responds with a DNS message. And you can just give it like a local DNS resolver, and it'll use that as a proxy. So we deploy this. It's totally no censorship, no logging. I couldn't afford logging if I wanted to. Yeah, true story. So you can try this out with Firefox. Just put anything in there. If you have a static website hosted on Commons Host, you can also put your own domain name there, which is kind of nice. And I think this is where it comes into the picture, where you can start like putting this into your own computers. If you have like a big network, you can set up your own domain name. And right now you can point this at the Commons Host network, but maybe like, Commons Host becomes corrupted and starts spying and logging everything. And then you just point your domain name somewhere else, and all your machines will just automatically try and move over to your current host, or you can be self-hosted. This is all open source. All of that good stuff. So then the second project, Donut, and this one has been really kind of like growing a lot. I don't do much on this. I spent a week building it, and sort of a lot of people keep downloading this thing. It's very popular for the Pi-hole crowd. This is how you can set up like a Pi-hole is like a DNS ad blocker. It's nothing to do with Node.js. I apologize, but it's a very popular thing that people run. Like they find these things in their drawer from like a couple of years ago, and they go like, "Hey, I can finally do something. It'll have a dashboard. It'll show me all my DNS traffic on my local network." And I can block ads and all these annoying like apps on my phone and my tablets. So people use that, and then you can sort of run Donut, which is like a little Node.js service, but it's available in a Docker image, so it's really easy to deploy. And that'll set up like a little proxy. It's kind of like it takes like on the left-hand side, it'll take traffic from your regular DNS over UDP clients, like your Pi-hole or any other device. And then it'll proxy it to a DOH service to upstream it. And it'll do a bunch of crazy stuff like shard the traffic across multiple services, or figure out which one's the fastest one, or just like spoof anonymous queries to like a set of realistic looking domains, just to make it sort of, if any DOH service that you're resolving to, it just has no clue what you're actually looking for versus what is the fake ones. So anyway, this is Donut, and it's really cool if you're using Pi-hole. I'm working on some more UI stuff, because I think it would be nice to have a little bit of dashboardy thing and sort of be able to run this on your own computer with more control. Right now, it's just a little Docker image with a config file and some environment variables. But there you go. So currently, I'm working on this idea that we can have a tier of servers in the CDN that would sort of, so you could take like a little Raspberry Pi, set it up at home, and configure it just for your own domain name to serve content within your local network. Now, you could make this public, but you could also set it up just to serve DNS, because that's the main use case. Serve DNS in your own local network as a DNS over HTTPS service with your own domain name, so that you can always, like I said, you always want to have full control, no lock-in. There's nothing proprietary about it. I wanted to have something that I could deploy at home, or maybe like in my office, or maybe a couple locations if I have a company with like a couple offices. But when I go outside, when I leave my house, I'm no longer using like my Pi-hole ad blocker from my local network. I want to fall back to like a SaaS, like some kind of cloud thing, and that would be like a network like Commons Host. But again, if you don't like Commons Host, you can set up your own Commons Host with your own domain name, and all the infrastructure and deployment stuff is all available. So that would sort of prevent the corruption from setting in, hopefully. That's the game theory behind it anyway. Hence the name Commons Host. There's a lot of things to that. So yeah, okay. If this at all appeals and you want to do a lot of Node stuff, and oh, I'm also like going to start playing with the Node Quick implementation for HTTP3 support. If you're looking at the GitHub for Node.js/Quick, it's been really active for the last week plus. The same folks that were working on HTTP2 are working on that now, and I've been too busy with all this relocating stuff here, but I'm going to dive into that and make sure that I can support that ASAP. So if you're interested in that, I could totally use some help. Just give it a try. Take a look at, see if it works. If you want, try deploying one. Wait, maybe like let's talk about the second tier of like just the small Raspberry Pis that you plug in to extend it on your local network. Yeah, if you want to deploy it in developing urban areas, I'm not sure if there's much of that in America, because things seem to be quite developed here. This is from a talk before. And I don't need you to give me money or anything like that. I'm just saying, like, you buy a little Raspberry Pi and set it up and just deploy it like that. And if you like it, please tell your friends and come talk to me afterwards. I would love to meet more people here. Thank you. No, so the question is sort of what does the hardware look like? And like, I'm really starting with the smallest thing I can find, which is like a little Raspberry Pi. It's also not at the ISP. It's more like on an ISP's customer's home network. So the ISPs don't really like that. But that's fine, because then they have an incentive to put it into their own data center when it gets obnoxious enough. So I just don't have the time and energy to go and change and talk to every single ISP in the world. That's sort of like a natural limit on current CDN networks. The administrative overhead, which is why I showed the example of like small ISPs around the world that have really bad peering and end up falling back and taking really inefficient network routes. So they would really benefit from having, more caches on their network. And so this is just one example of doing that. And the reason why for making all this open source and open standards based and fully transparent is that I think it's more like a concept, more like an idea. Now it could accidentally work, but it's sort of just meant to inspire that we should have more technology and standards to help small ISPs and then be less centralized and exposed to sort of single points of failure with our privacy and all of that. Yeah, you could. So you could have either. So the way to deploy this kind of infrastructure is if you have fiber at all these apartments. That was the inspiration. Like, why don't you just put like a bunch of like small boxes on every single one of them? You have more reliability. Maybe it's less energy efficient in some ways, but at the end of the day, if they're on the same network in the same city, you have like sort of like it's like putting things on the AWS availability zones. If you're putting them on like multiple ISPs and multiple different buildings, chances are that the power isn't going to go out into like all buildings at the same time, right? So you have some built-in resilience in the nature of deployment of multiple locations, and you might get more performance per dollar if you deployed like a large server. That's why they exist. But if you're spreading the cost, maybe that doesn't matter so much. So there's like trade-offs, basically, is what I'm saying. So you could just deploy. You could figure out that, oh, at some point it becomes more economical to deploy a large server. You could do that. Like, this doesn't have to be a small server. That's just what I can afford. And how to get started and bootstrap this thing. But you could say like, oh, I'm going to put like a 96 core Xeon server in here and serve 200 gigabit per second in one city, because there's a lot of demand for it there, for example. But so you can scale that, right? So yes, sir.
Question. So what's that step on the application again, rather than Python?
Everyone does.
So I can set up DNS, and I can set up CDN. And I apologize, I don't know DNS very well. But how does the DNS get talking to my ISP network? How does that work? And then,
okay. So I was pretty much there myself 6 months ago. DNS is still somewhat of a mystery, but what I've implemented now is that I sort of run side by side on the same little node. I run this DNS over HTTPS proxy, and it just talks to like a local host DNS resolver, and that resolver doesn't like rely on like the Google public DNS or the ISP's DNS. It does its own sort of full recursive lookups. So it goes and says like, oh, if you're looking for like example.com, it'll look for it'll contact the root server for what is the .com part or the com dot part, and then from com it'll go up like what is example, and then it'll sort of recursively do all that, cache it all locally, and so it becomes its own resolver, fully like independent. That's the idea, and that's where the shared caching would come in, where like if you were to expose that within your local network, more than one user, right? Chances are you're looking for the same, like if you're using DuckDuckGo or whatever, probably a lot of other users are using the same DuckDuckGo, and so they get the benefit from not having to do their own lookups every time. Now you're not sharing that across ISP, but you're sharing that with local. So you could say, oh, what if I want to share it across ISP? Well, I could, if I have a public IP address at home, I could open up a port and say like anyone in my ISP can now contact my DNS resolver as well and use that, you benefit from that cache. But they would be exposing themselves to you potentially spying on them. So there's like a bunch of security questions there. Hence some of these sort of what they call countermeasure technologies, like spoofing queries. Just like because you have excess capacity, then just like throw more queries at it. You can't figure out which ones are the real ones. There's just some ideas out there. What was your second question? Yeah, so they're basically two applications of what you can do with a network of servers. I mean, they don't take like all the memory or anything. It's just a little middleware that's transferring, like taking in, like listening for HTTP requests, sending it to a little local, DNS resolver, and piping it back out. So it's all very, very lightweight. Do you mean like in terms of the resource?
Well, I just never thought about putting it together.
Okay.
CDN, I think CDN POS insane.
Mm-hmm. Yeah. So you could, yeah. But the goal is to have as many boxes around the world, and if I can make them dual purpose, then I just double the number of boxes that I have available for either. Yes.
So I wanted to get a question about the CDN side of it. So I create a little simple static website, calculated how much was. I create a custom domain that handles for me. Does that get pushed up to all the nodes and stored on these Raspberry Pis and all various locations?
Yes. So that's a very good question. I've been extremely ruthless about not doing things that I can get away with not doing, and it's a really sort of naive, simplistic, inefficient, unscalable model right now, where every single POP around the world has a hard drive attached, and they all mirror the exact same content from like some S3 bucket or something. This doesn't, so it's kind of like constrained by the smallest server on the network. I've got a huge pull request that like changes all that to become sort of lazy loading and locally caching. So it'll be more efficient then.
Second question.
Sure.
So right now it's uploaded to all the, say there's 20 nodes, 20 versions.
There's about 30 deployed and about 20 active.
Okay, so they get this static website gets pushed up to 20, 30 nodes, and you have this, it's a CDN node application, right, running on these Raspberry Pis.
Correct.
And it's just serving, it's over HTTP2, so you just request it, comes back, does.
It's a static file server.
Just a simple static.
So if you look at the HTTP2 API, it's like there's like a little. It's a very simple thing. It mimics what Nginx does. So it just listens for stuff. There's no like Nginx on the box or anything. It's pure Node. Because of the hardware constraints, I mean, this is a premature optimization. I never really tested that, but I figured that I would just like have Node listen for the socket with the HTTP2 API. You can also respond, like you can send files using a file descriptor. So the underlying library called ng-http2, it's like it's a C++ or a C library. It's been a while. That will just take the file handle, file descriptor, and pass it over to that socket and do the whole thing very, very low level. So that's how you can saturate a gigabit connection if you're serving like larger files. If the requests per second might not be as high. I've done a bunch of benchmarks around that part. So if you're serving like, if you're streaming video, you know, you're doing chunks of like hundreds of kilobytes at a time, you can saturate a gigabit on a very cheap device with encryption. If you're doing like really small front-end files, I don't know the numbers exactly, but if you're serving like lots of like 4K files or couple hundred bytes, like a little CSS file, if you don't concatenate it, you end up with like a ton of files that are like a couple hundred bytes, right? There might be more overhead there per request, so maybe a little bit more expensive. But so far so good. Yes, sir.
A couple of questions. First, so anyone can get these boxes if they wanted to join the CDN network?
Yes, anyone can do it.
You have obviously SSL certificates in your version. Yes.
Yes.
And you establish trust that someone's not going to take your weird box apart and get a bunch of SSL certificates.
Right now, there's not that many, so I kind of I know them. So there's no like magic lines for that.
You don't have a magic file now, but anyone can just.
No, definitely not. This is an inherent part. So that's why I would not do this. That's why it doesn't scale right now. There's no technical solution to that. There's people are experimenting with like lower, like you could basically like continuously scan with any kind of intrusion, but ultimately if they have the hardware, it's compromised. You have to sort of assume that there's all this. You can put thermite into the case and they open it up and self-destruct. That's kind of crazy. So I want people to be able to contribute their own hardware, and the best solution is that they can only serve their own content to themselves, which sort of sounds like it defeats the purpose, but that's where the DNS thing works very well. If you have DNS over HTTPS, you could have your own domain name and only serve your own domain name. So the idea is that the way the design works is that you connect to like yourdomain.com, which resolves to sort of this public network that I could manage, or that would have trusted servers. They could be like cloud servers or whatever. That may be like a few hundred locations around the world. Once you connect to that, the first request for like initial DNS queries starts going out. The responses could include a little thing called an alternative service header or an HTTP frame that announces like all the other servers for that domain that are also willing to respond to DNS over HTTPS queries. And those would include things like 192.168. Blah blah. Like your own private local network. Raspberry Pi that's listening only on your network. So only on your own network would it be able to respond with a valid certificate, because it would have issued a valid certificate because you own that box and it's your domain name. And so there's no reason that you can hack yourself, right? So that would be like sort of like the limit in terms of the design, how to work within that constraint. It's like you can only you can have this huge network of edge servers, but they would only serve your own stuff. Now in the longer term, if I want to be able to like publish content, you can't trust the servers. They will tamper with it. So the only thing that you can do is sign the content. And there's things like So, well, there's DNSSEC and things like that, right? But applying it to web content, you could look at I think it's confusingly called Webpack, I think. There's a W3C or ITF proposal by some Google folks, I think from the AMP project. Is the P stand for project? I'm sorry. From AMP. Oh, okay, AMP project. So anyway, so they've been working with some of this stuff because they also have the problem with the domain name when you look at like a little AMP Google search result and it pops up at AMP. Am I out of time? Is that a very subtle hint? Okay. Anyway, so they have the same issue where like they want to put your content from your own domain on the, but not showing their domain. So it's along those lines that they would basically sign all of these web assets and then serve them through untrusted connections, even like down to like sharing through Bluetooth with each other and stuff like that, or offline transfer. Like somebody could definitely tamper with the files, but if they did, then you would see that they're no longer signed and validated, and you wouldn't load them. So therefore, denying the reason to tamper. So that along in the longer term, I think that would be a good option. There's things like you can do sub-resource signatures, I think, right now on websites. But that only works if you're then using the CDN for like the third-party requests. Yeah. Sorry. Does that help?
Yeah.
Thank you. One question too. Maybe one more question there.
So they said that publish entire websites to those.
Yes. Yes, sir.
So how much do they want that cache?
So I have a bunch of them out there with like, my budget was about $50 US roughly, I think, for the storage. And I ended up buying the last batch was about 500 gigabytes of some SSD on Amazon. And so, but there's some of them out there that only have like 20 gigs, like a line OGPS or something. And so if I start caching more than that, those nodes won't be able to serve any content. So that's why I need to move to this model where like I'm working on this refactor where it would just cache dynamically, which would also let it just cache anything, any web content. So you could just give it any origin, you could give it an API, and as long as it has cache control headers, it would just respect that and cache those things as well. So it will be much more flexible once I have that in place, both in terms of being able to scale up to servers with more storage and lesser storage, as well as the types of content, which is right now just like I said, it's just mirroring. It's like S3 CMD sync this S3 bucket whenever somebody deploys. It's just terribly inefficient. It's doing lots of S3 API calls and it's costing me too much money there. We're talking about dollars a month. Right?
Do you still have hardware in Singapore?
No, I mean personally, I personally don't. I put it all with Kenny, my friend. So he's running the API server on a little Odroid, and then he's running an edge cache. And there's like 3 or 4 more servers like at different people's homes in Singapore, because I gave this talk there, and people were like, "Oh yeah, I'll support." The closest one here, I think, is in Dallas. I don't have Austin yet. Don't have fiber here yet either. There's not many. Does anyone here have a fiber interconnection? Yes. Yes. Which ISPs are good? Do you recommend anything? You have Google Fi. Ooh, cool. And AT&T. Is that goes under a different name? Your Spectrum, is that correct?
No, that's Time Warner.
Oh, is that different? Okay.
Spectrum's Time Warner and Charter merged into Spectrum.
Oh, good. Thank you. All right, that was my question for you guys. Okay, thanks.
I was just wondering if you were, on your own team, or you had a, multi-international team.
Oh, you mean working on this, like collaborate with us? So most of the coding has just been myself, but Kenny, who I showed in the photo there, he's been really helpful. So he's just based out of Singapore as well. We've been friends. So he's the co-founder of that very first JavaScript. He's the first person I ever saw giving a talk about Node.js. And now we're going to do a meetup about this, just like this. Then people who are hosting these servers, they're also collaborators in a sense. They're pretty much around the world, I'd say. Mostly Asia, Europe, America. Don't have Africa yet. Don't have South America yet. So if you have any friends there, let me know.
How do you push updates to these nodes?
Ansible. So it's like automated SSH. So I haven't deployed the latest what's it called? Node Erbium, whatever, or the new one. But basically, it's just like there's a if you look at gitlab.com/commons/host/ansible, that's all the config files are, everything's there, with a list of all the nodes that it deploys to, all the hosts.
So you just reach out to every single one of the nodes rather than having a central update and check or something like that, and have the nodes call out.
Correct. Yeah, that's kind of I don't know. I mean, it was just sort of like that's like I didn't know Ansible or Salt or any of those things, so I just like learned it as I went. Yeah, I blame Kenny for Ansible, but I mean, I also thank him for that. No, do you have any other ideas? And I would happily discuss that. Thank you very much.